Okay, in today's lesson, we are doing lesson 4, the area of polygons through composition and decomposition. Okay, composition and decomposition. We are going to be tearing things apart. We're going to be putting them together. Okay, so let's do the opening exercise. Here's an aerial view of a wood lot. Okay, so then they give us afterwards some measurements. If AB is 10 units, so line segment AB is going to be 10 units. FE is 8 units, so find FE is 8. AF is 6 units. And DE is 7 units. Okay, here's DE. Find the lengths of both other sides. Okay, this is pretty fun. So I need to find DC and I need to find BC. Okay, I'm going to start with BC. Okay, it's the whole length of the wood lot. Okay. So I know that if this was a whole rectangle, and I'm actually going to draw an imaginary line, and I hope you do on your paper, that this whole line would be congruent to this whole line, because opposite sides of a rectangle are equal. Okay, but I know from here to here is 6, so I have to figure out what here to here is. So I'm actually going to use from here to here is 7, so this is 7. Okay. So then, now I add both parts of this, 6 plus 7, and I get 13 for a length of BC. Now, I have to find the measurement for DC, okay? And I look up on top here. This whole line is AB, so I know this whole thing down here has to be AB, okay? So I'm actually going to try to figure out what this part is right here, and I'm going to look up. FE is 8. So that means this section right here also has to be 8. And I have to think 8 plus what number is going to give me a whole side length of 10. And it's going to be 2. Okay? So DC is going to be 2. Okay, that was pretty easy. Okay, so what I'd like you to do right now is ask your teacher to pause the video that you're watching, and I would like you to try this. Okay? Try it on your own. Maybe you get 2 minutes. Okay? And then when you're done, hit pause and you can watch the solution. Okay. If DC is 10 units, FE is 30 units, AF is 28 units, and BC is 54 units, find the lengths of other sides. Okay. I'm wondering if I can do the same thing. Okay, I'm going to use that to help me. AB I have to find. So from here to here, I don't know. Okay, so I'm going to use FE. From here to here is 30. So that means from here to here is also 30. So if I add those 2 side lengths here, 30 plus 10 gives me a length for AB of 40. Okay, now I have to find line segment DE, just this section right here. So I have to go over here to kind of help me figure it out. I know from here to here is 28. I know this whole side is 54. So I know I have to do 54 minus 28. And when you do 54 minus 28, you are going to get a side length for DE for this one of 26, which means DE is also 26, okay? Breaking these shapes up, finding missing parts is all going to help us calculate area of all of these irregular figures. It's pretty fun, okay? Let's go to the next one. I'm going to go through a couple of examples with you, and I'm going to show you a couple of different ways to do it, okay? The first example, we're decomposing polygons into rectangles. So the intermediate school is producing a play that needs a special stage built. A diagram is shown below, not to scale. On the first diagram, divide the stage into 3 rectangles using 2 horizontal lines. I know horizontal is side to side because these are side to side, okay? So I have to use 2 side to side lines. Find the dimensions of these rectangles and calculate the area of each. Then find the total area of the stage. Okay, so looking at my irregular figure, I'm actually going to draw 2 horizontal lines here. I have just cut that into 1, 2, 3 shapes. They appear to be 3 rectangles, and this could possibly be a square. But I don't know yet because I don't know all the dimensions. but I know that the area formula for squares or rectangles is area is length times width. So I'm actually going to write that down 3 times, and I hope you are doing it too, okay? I'm going to start with triangle number 1. I know this side is 2 for length. Now I have to find the width. So I'm going to go over to this neighboring rectangle, which has both of the measurements already. Okay, so I'm going to go over to my rectangle number 3 here. The length is 2, the width is 4. 2 times 4 gives you 8. Please do not go divide by 2 half of your numbers. Division by 2 is only for area of triangles because they're half of a quadrilateral, okay? So the area of this guy is 8 square meters. Yes, Mr. Anderson would probably like it if they were able to units, okay? Now, because this one was 2 times 4, I know this one is going to be 2 times 4 meters. Okay, so I have 2 times 4. So the area of rectangle number 1 is also going to be 8 square meters, or 8 meters squared. All right, last one to go. Okay, the second one. I can see I have a length of 7 and a width I'm not sure of, so I'm going to have to calculate it. Okay, over here, this dimension tells me this whole side is 9, okay? The whole thing. And I know from here to here is 4, so that means from here to here is also 4. So I have to think 4 plus what width is going to give me a whole side length of 9. And it's going to be 5, because 5 plus 4 gives you 9. So if this side's 5, this side's also 5. So my area is going to be 7 times 5, and the area is going to be 35 meters squared. Now, to find the area of the whole stage, you have to add all 3 of these together. 8 plus 8, quick mental math, is 16. So the whole stage has an area of 51 meters squared. Okay? So that's a great way to do it. Okay? We just cut this irregular figure, we're decomposing it, and we are composing it now of 3 rectangles. Okay? So let's go down to B. They're going to give us the same one for B, but they're going to ask us now, instead of doing horizontal lines, they want us to divide the stage into 3 rectangles using 2 vertical lines. Since B's are up and down, I know that they want 2 lines up and down. So I'm actually draw a line here, draw a line here. Okay, so now I'm going to have to fill out some missing things. Okay, I know this whole side is 9, so that means this whole side is 9. That's going to help me. I'm going to write my area formula down 3 times, because I have 3 rectangles. And this first one's so easy, 2 times 9. So the first rectangle has an area of 18 meters squared, which means I'm going to make life easier on myself. The third one over here is also going to be 2 times 9. 2 times 9, okay? So the area here is also 18 meters squared. And now I gotta find this guy. Don't use 7. 7 is the whole side length, okay? But now I have it cut into 3 sections, so I have to figure out what this middle section's length is. From here to here is 2, so that means from here to here is 2. From here to here is 2. So now I have to figure out this whole side length is 7. Here is 2, here is 2. This side has to be 3. Because 2 plus 3 is 5, plus 2 is 7. So this is 3, and I have to figure out how tall this is. And I remember from the problem we just did, because this whole thing is 9, this has to be 5, because 4 plus 5 is 9. And I'm going to do 3 times 5, which is going to give me an area of 15 square meters. Okay, 2 different ways to do the same problem, but again, when you add these two, 18 plus 18, quick mental math is 36. If I add 15 to it, I'm going to get the same area for this stage that I did with the first problem, but we did it in different ways just to show you that you can cut it into a million different shapes probably and still come up with the same answer. Just have to be able to calculate the dimensions correctly. Okay, I'm gonna ignore the directions for this one. I'm gonna come up with my own, okay? You don't only have to necessarily cut the irregular figure into different shapes. You can actually also find the area of the whole entire figure, which will do that. And then you can find the area of this little section, and you can subtract it out, okay? Some people's brain might see that a little easier, okay? So I'm going to need two area formulas. In order to find the area of the whole rectangle, I'm going to do 7 times 9, okay? Because that's going to give me the whole rectangle. That would give me 63 meters squared. Now, from that 63, remember I'm trying to get to that area of 51, I can take this rectangle to find its area and subtract it from this guy. So this from here to here is 4. From here to here, we decided was 4. This is pretty nice. We decided was 3, because this whole side is 7. So 2 plus 3 is 5, plus 2 is 7. So length times width, 3 times 4 is 12. So I'm going to do 3 times 4. The area of that pink rectangle is 12 meters squared. So when you take 63 and you subtract 12 from it, we got the magic number of 51 meters squared, okay? Just a different way to look at it, okay? We just found the area of the whole thing and X that guy out, okay? I'm actually going to skip number 2 because this one is a parallelogram, and that was lesson 1. Base times height, okay? The base of this parallelogram is 6. The height is 4. So this should be a very easy one for you. The area of this parallelogram is 24 square meters. Okay, and I'm going to go right to number 3. Love this one. This is the most missed on your homework last night. The trapezoid below is a scale drawing of a garden plot. 6th grade standard. You can take any irregular figure and chop it into triangles. Triangles are the most important thing to understand the area of in 6th grade. So now I have a triangle here, I have a triangle here. This one is acute, this one's obtuse. I'm going to write my area formula down 2 times. So we have just cut this trapezoid, and we have composed it of 2 triangles. Okay, so the first triangle, I'm going to say this is number 1, this is number 2. The first triangle is upside down. Okay, no biggie. The base is 4. Now I have to calculate the height, okay? But I know height is from the top of the shape all the way to the bottom of my obtuse, and it has to make a 90-degree angle. So I have to find something that's measuring from here to here. So I'm going to look through this whole trapezoid, and ding, 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 from here to here is 5. So that means from here to here is also 5. Okay, that's going to be your height. So your base is a measure of 4 units long. Your height is 5. And don't forget to divide by 2 for a triangle. T, triangle, T, 2, divide triangle by 2. Because they are half of a quadrilateral. 4 times 5 is 20. 20 divided by 2 is 10. So your area is 10 meters squared. Okay, so this guy's 10. Alright, triangle number 2. Its base is 8. This has a 90-degree angle too if I want to add it in. My height is 5, and I have to divide it by 2. 8 times 5 is 40. 40 divided by 2 is going to give you an area of 20 square meters. And when I add the 2 of them together, this whole trapezoid has an area of 30 square meters. Kind of fun. Last one. Love it. It's a kite. This kite is split into 1, 2, 3, 4 triangles. So I'm going to actually only write the formula down 2 times, and I'm going to tell you why. I'm going to try to work smarter. I'm going to say that this is the first triangle right here. Okay, and I know there's a 90-degree angle right here. Okay, put a little box in it. I'm going to say my base is 4. My height is 3. And then I'm going to divide it by 2. 4 times 3 is 12. And 12 divided by 2 is 6. 6 meters squared. Okay? So this triangle has an area of 6. And I only wrote that down once because this triangle has a base of 4 and a height of 3. They're the same thing. Okay, so there's going to be a 6 here too. Okay. Alright, so now let's do the second triangle right here. Okay, which is a duplicate down here on the bottom. And I'm going to put my 90-degree angle in it so I can figure out the base and the height because it's touching the 90-degree angle. The base is 9 meters. The height is 3. Okay, and then I have to, since it's a triangle, divide it by 2. So 27 divided by 2 is actually going to give me an area of 13.5. Okay, so I have a 13.5 area here. I have a 13.5 area here since they have the same dimensions. Okay, now when I add this all together, 6 plus 6, 12, 13.5 plus 13.5, the total area of that height is 39 meters squared. Okay, I hope that this is a good explanation of decomposing and composing irregular figures into other shapes to calculate its area. I do want to show you one more trick for a triangle. I learned this, okay, a long time ago. You can take the whole side here and multiply it by the whole side here and divide it by 2 to calculate the area. Let's see if it works. 3 plus 3 gives us a length here of 6. 9 plus 4 gives us an area of 13, and then I'm going to divide it by 2. Okay, so let me take my calculator out. I'm looking for 39. Okay, so let's do 6 times 13. It's 78, and 78 divided by 2 is 39. So if you like that way better, go for it. Okay, 39 meters squared. Okay, you take the whole length of the height of your kite with the width of your kite, multiply them together, and divide by 2. Good luck with your edging, Hannah.